Firstly, apologies for the delay on the blueprint run-through on this. I got slightly distracted creating another prototype, and it was I hadn't really finished this one in terms of talking through what I had done. So first things first, let's just look at our actor blueprint, which is mineral setup. And in here I have got just the creation of the HUD, setting a local variable and adding it to the viewport. We'll look into the HUD earth element shortly. I've enabled inputs because I am using a spacebar here to demo the labels, which is just a kind of bit of debugging tool for me. And I am executing a console command, the rtemporal AA upsampling 0, which basically cleans up some of the artifacting on depth of field. That will make sense shortly. So if we look in our world again, we have our main actor, which is our mineral actor, and this actor is just instanced where I have changed the static mesh and the material. I've also then got some exposed variables, so a mineral array, which is float, an index integer, a number, text, this is based on the periodic table abbreviation text, the name text, and I did some tests using linear color to carry on through as well, so that's an array. So all of those have got their instance editable clicked, and then index has got the expose on spawn also checked. I'm not sure I'm using that anymore, but you know, if you're spawning actors into the world and you want to be able to pass variables through, then you have to make sure you have expose on spawn checked. If you want to set any values to variables using the spawn actor node. So the only thing that I've got in here in terms of the blueprint is I have got a random float in range to set the rotation rate of the rotating movement component. So just something that gets the mineral rotating in the scene. That's quite straightforward. Coming back to our world, then when I have got each of those instances placed in the scene, I can then come through and update that information. So my mineral array, I've got 3 values that I've just hard coded. Again, this could be brought in from a Google Sheet or a data table, but I just wanted to give it some values to work with, because these values here, our mineral array, get pulled into our HUD. It sees how many elements are in that array and then creates a pie chart for each of those values and then draws that in. So in that instance, there's 3 values. Here we have got 8 values. So yeah, I just wanted to add some variation in here. And then I've also got the labels for them. So here this is thorium, which has the abbreviation TH and the number 90 in the periodic table. I've defaulted these out to white, but these were the colors that I wanted to assign to each of those values. That's why there's 8 values and 8 colors, because I wanted to do a test where, rather than the pie chart just rendering in transparent values of white, I wanted it to be in different colors. So that was just an option, more just from a kind of design iteration point of view, just to see how it would look. So I've kept it to white. That was a kind of design choice at the end of it all. So they're the only things that are placed in the world, other than kind of a few other things like the directional light and exponential height fog. But in terms of our actors in the world, it's just instances of the mineral and our setup actor, which it has a post-process component in there, which is my usual trick just for easier referencing. So let's have a look at the HUD. So if we come just to the visual at the moment, we have our main parent HUD, Earth element parent, and here I've got those 3 text blocks which are then assigned to the number, periodic table number, abbreviation and name. So they are each bound to a text variable and are updated when the line trace hits the static mesh and we're passing through those values to update this mesh. Now I've just got a little image in the middle which demarks the center of our widget, so that's our target. That in effect gives us a site to aim with, and we have a line trace which is being drawn from the camera pivot to the object. So because our aim image is in the center of the widget and we are in effect line tracing from the center of our view from the camera, that aligns. So it kind of correlates with what you are hitting. We have our focus dynamic image. Now these are the dotted lines around the pie charts that scale and rotate based on the focal distance value. And I've just got a logo here. Just coming back to that image, I'll go through the images in a moment because there's a few sort of complexities there, but just to say that the pie charts are created with materials. That's the way to kind of go about drawing out these pie charts. That will make sense shortly. So if we look at the children that come into our parent, we've got 2 other widgets. So we have our label child, and here we have a widget that is 700 pixels by 50. The anchor for that is basically placed on the left at the side because we're spawning it in the center of the screen, and then we're rotating this. We're giving this a render transform so that our labels rotate around potentially 360 degrees and align with our pie chart segments, the end of our pie chart segments. So if I just play that demo a second, you'll see that the labels are aligned with the end of the pie chart segments. And if I press space, this was just to sort of randomly generate some other sections. And you can see that the labels are rotated around the pie charts. The second child is the pie chart material itself, and that is a widget of 650 pixels by 650 with a anchor bang in the middle, so it draws on the center of our parent widget. And at the moment the material is actually fully drawn, and you may have noticed that when I pressed the space bar to trigger the refire, when I pressed space and was recreating the widgets, the circle was filled and then it animated to its value. That's because it's already full. If I come and actually make that radial 0, so it doesn't draw on the screen, and apply that, if I then play again, it will now draw on from 0. So the value in the default material has a bearing on the effect, basically. So now every time I focus on a new object, the pie charts draw from 12 o'clock and fill, whereas before having that value at 1, it was full already and emptied to their respective values. So that's just something to bear in mind, that your default values in the material has an effect on the result. So it really depends on what you want, but the best way of ascertaining that is through a lot of trial and error and just trying things out. So coming back to our Earth element parent, this is where the blueprint handles the creation of all the child widgets and pulls through their values and applies the render transforms and effectively draws the pie charts based on our line trace hitting a particular mesh. So let's have a look here. What have we got? We've got our event, reconstruct, refire, and just adding a reference to this widget to our game instance. I've got just a custom event here to clear out any of my arrays should I need to. My refire in effect just handles the first, the reason I've put this here is because I'm then calling this custom event from elsewhere, so I've just done it once basically. So we are doing a few things. If you recall, in our actor, our instance actor, we had a different array, and in that array we had a target value. We're passing that through, but the length of that array is determining how many times our for each loop is running, and therefore how many children we are creating because of our line trace. I'm actually going to come to the first person because I think this is going to make more sense. So let's have a look at the additional nodes that I've put into the first person character. I've taken out a few components like the gun and anything to do with projectiles. But what I have added, I have got a sphere trace to detect whether or not we have got the mineral actor in our sphere trace, which is firing from our pivot point and our cine camera. And the sphere trace is with a radius of 10. Now, this is a little bit more expensive, but it can garner better results, because if sometimes you just rely on a single line trace, the trace doesn't necessarily always hit. I'm not sure what that depends on, direction of the normals or something perhaps, but this gave me better results. So I've got a sphere trace set on a timer, so it's just every 0.2 of a second. I am using the visibility channel, and I'm tracing complex so that we're hitting the complex collision of our mineral actor. So on our out hit actor, I'm seeing if the object is one of our instances of our mineral actor. If it is, then I'm just setting that locally as a variable, just to clean up some of the spaghetti moving forwards. If it doesn't hit one of those actors, I've got some functionality happening on the fail, which we'll go into in a minute. So let me explain what's going on here in terms of our cast, and then whether our cast is successful or fails. So this is important because of this do once. Now, sphere trace is going to continually fire unless you tell it not to. So for example here, we are saying, firstly, if we are hitting an instance of our mineral actor, great, that's cool. Now, because we're firing over and over, we're saying if our index equals our current index, do nothing, true. If it's false, i.e., are we now looking at a new mineral actor instance, trigger this, but only do it once. We're setting the current index based on our new index. But if this isn't here, then that becomes a loop and constantly refires. So when we are looking away from any actor, we're setting current index to -1, because none of our actors have an index of -1. So it will always be different when we look at a new actor. So this is a way of clearing that value. And when we're looking away, that is then resetting our do once. So as soon as we look away from a mineral actor, this gate gets reopened so that when this happens again, it does it once. So that then handles our interaction and means that we can look around each of the actors, even coming back to the same actor, and everything fires as expected. Now there are a couple of custom events in here which are on our parent widget, which sets some values for a float interpolation, which handles the way that the autofocus material is rendered on screen. So it handles our animation of that element. So if we come to our HUD, here are those custom events. So these are the values, the target values for these f-interps here, which are updating a material parameter collection scalar parameter value for that material. So this is the focus material, this is also the focus material, and this is the focus amount, i.e. how many lines that focus material gets divided up by. I'll explain that when we look at the material. But by changing these values, you can get different effects. So let's have a look at just swapping this out a second. I can't remember what this looks like even. But I think it's more like a sort of square based, yeah, that's right. So the lines are coming in from the edge of the material. You know, that's just one of the things that happened when I was experimenting. I've lost it now. I don't know what's happened there. Why has that happened? Anyway, that's not what I went for in the end. I preferred these settings here. I'll make it full screen. A little bit more subtle. Then as we move closer, you can see that the goes clockwise or anti-clockwise, depending on moving forwards and backwards. And it's all dependent on the focus distance value that's helping drive a scalar parameter in that material. So coming back to our for each loop in our parent widget, we are doing a few things. We are creating a child, which is our pi segment. This is our, if you recall, our pi segment, which is the full pi, and then we have our labels. So we've used the index value to get the target value from the array, and then passing that through into this custom event that is part of our child widget. In my pie chart in the child widget, I do have some blueprinting. So I'm passing through the value because we're taking the value from an array and passing it to each of the individual children. And then I'm also affecting the interp speed from the parent. And then I'm just using those in another f-interp to affect the scalar parameter value of a dynamic version of that material. So the child image has the donut pi material applied. I'm getting a dynamic material from that. So it's the equivalent of a create dynamic material instance, but this is for a image in a widget. And then I am changing the value based on our target value. And because I can constantly compare the current to the target value, whenever I change that target value, it will animate to that new position. So that's within our child donut pi segment. And then the label child, I've got just a fade up animation here. The rotation of that is handled in the parent. So we'll come to that in a second. So our donut pi segment children get added to the canvas. So just to reiterate, this is where we are creating the array index target value variable by accessing the target value array using the array index and a getter. So our target value array, if we've got 3 values in our pie chart, it will be 0, 1, 2. So then we are running a for each loop based on the length of that array. So if you recall, we had some which were 3 and some which were 8 and whatever. So then for each of those in the for each loop, we're creating a child pie segment and passing through its respective value. Adding the child to the canvas. Now in here I've got 2 canvases. I've got one canvas specifically for children and then another canvas which just holds the rest of the graphics. So it means that I can clear children for this canvas and all my kind of permanent graphics don't get deleted. I didn't appreciate you could have 2 canvases in the same widget, but you can. So you can set up a separate canvas panel just for children. So that's really helpful. And so there we are. There's our canvas panel for children, which as you'll see here, I'm clearing specifically just that canvas. So for each of the segments, we're adding that to a canvas slot array and then also a segment child. And for each of those, I'm just doing a little bit of realignments, making sure that the anchors are set to center and that the alignment is also centered. Our second part of the sequence is then creating our labels. Donut label child. I'm playing that animation which just fades up. I'm adding it to its own arrays and then setting the anchor alignment and position. Firstly, our labels get spawned and then we are taking the value of the segment and then I'm running it through a map range clamped, which then takes that 0 to 1 value and remaps it from -180 to 180 degrees. And with a bit of trial and error, I had to add 90 to get that alignment to work. So we're taking our text pivot, which is a horizontal box, I believe. Yeah, text pivot, horizontal box. And then I am rotating it, basically setting the render transform angle to that angle. And then here, because we're rotating from 12 o'clock around, if any of the labels end up being upside down, I'm just taking the text, they're the threshold for whether or not the label was upside down. Again, just through a bit of trial and error, and I'm just flipping the text label component in that widget, label text, and we're just rotating that by setting its own render transform between 0 when it's right reading or 180 if either of those conditions is true. So that handles the positioning and the orientation of the labels based on the angle of the material. Let's talk materials. So if we come to our pie chart material, now let me just add in a value here just so it draws. So you see we have 2 radial gradient exponentials where I'm just subtracting one from the other because they're different sizes. Basically, this is the outer at 4.75 and this is the inner at 4.25, and this one subtracted from that one gives us this kind of donut. So if I change that down to whatever 0.2, you'll see it just is a smaller radial exponent that we're subtracting. And because I'm then plugging that in to the opacity with our dial information, we can affect that. value dynamically by having it as a parameter. So that's how we're handling the donut. I'll just put that there so you can have a little screen grab. We're doing something slightly different for the autofocus material. Similar, but we've got 4 circles. Because rather than a donut, we've got a kind of double donut that we're playing around with the parameters and animating those using f-interps. And that gives us that smooth animation of the disks increasing and decreasing in size and affecting a value for how many divisions there are. And it's just playing around with those in an f-interp that gives me that sort of smooth animation, which again was just a bit of trial and error and a bit of an experiment, but to kind of have that control purely on a material and it be kind of procedural, I think it's amazing. It's quite a lot of fun experimenting with that. So let me find the right material. If we come to our main HUD, of course, that's where it is. It was here, focus dynamic image, focus circle. So as I say, I've got a big donut with a smaller donut, and I'm subtracting those two. So there we are. We've got that result. And these values are quite close. I've got 0.5, 0.4, and then 0.495. So just 5 thousandths either side. That gives us that fine line. And then I've also got this sort of percent value. Are we using that? Yeah, we are. So actually, I'm not changing that. That's just set to 1. But what is giving us the focus rim scale is this piece of code here, which gives us how many divisions. Let me just see something. If I give that default value, focus amount of 30, just so that we've got something in the material itself, you'll now see that we've got this sine wave here. And if I preview that, will it give me that? Yeah. So we're taking this and multiplying it with our circle, which gives us the dotted lines, and we're plugging that into the opacity. But what we're then also doing, if I can bring that in, if we're changing that material parameter collection, we're affecting that line. So we're doing a couple of things. We're affecting that line by playing around with f-interps on that value, but I'm also playing around with these values. These are just my kind of local reference. They are all material parameter collections as well. So if I come in here and play around with that, you can see by playing around with these values, you can kind of get different effects. And if you recall, when we were in our first person character and I was triggering these are the targets that I was updating, which handle this material parameter collection scalars that are in those two materials. So this was all a bit of trial and error and just playing around and seeing what effects you could get with it. But I was quite pleased with the kind of, not necessarily the end result, the current result. And it was more really to see what you can do with f-interps. So there you go, it fades out. Nope, let me go full screen. And that, in concert with the pie chart, I thought was quite interesting with the values, and you can kind of keep triggering things. And that's really the kind of fundamentals of what went into kind of creating this. There is also a bit of auto-focusing going on with a secondary line trace, so let me show you that. So some of you may have seen some of my other videos, and you would have seen that I tend to set up a separate trace channel, which you can do in project settings. If you just search for trace channel, and then you can add your own trace channel. Obviously you have visibility and camera as defaults. I set up a separate one here for focus, and taking from my cine camera position with a trace distance of 30,000 in this case, seeing if I'm hitting an instance of our mineral actor. If we're not, I'm setting some cast fail default values that just is a greater depth of field. If I am hitting one of the actors, I'm then setting a narrower depth of field, so we're getting that really acute depth of field. Then we're taking the distance, we're just dumbing it down a little bit by 100, but because this is constantly updating and we're passing it through to our parent widget, it's being updated here on the finterp, which in turn is updating the scalar parameter value, which in turn is dealing with driving this value, which gives us some variation on the number of radial lines on our vector to radial value here. So all of that kind of plugs into each other, and that's the effect that you get. I think I've covered everything. So I hope that video is of use. If so, please do like and subscribe and hit the notification bell to receive any updates. And thank you for your support.